Welcome to the 5th video of the ELS New Features video series. Today we'll be discussing the topic of soft story drift. Earthquake loads have a significant effect on high-rise buildings, especially if there is a soft story. A soft story is a structural design in which there are no walls, only skeleton objects exist. Rotation of the columns in the soft story is a very important issue when the structure is subjected to seismic loading and an important factor to consider when using dynamic analysis. In structural analysis, soft story's drift is measured by the angle between the column under loading and the original vertical orientation. An increase in story drift means a higher probability for failure to occur in the soft story. In this example, we will walk you through how to calculate story drift for the entire structure. Let's get started. So this building I'm showing here is a good example of a soft story. You can see that it has a level in which there is no masonry walls, just columns. So let's take a look at the earthquake load that we will apply to this model. Okay, let's now run the solver and take a look at our results. Here are the results shown in the ELS viewer where we can post-process the analysis results. So to look at soft story drift, let's take a look at the model in plan view. I'm then going to select one element in all of the levels. Now, just to hide everything else to make it easier to look at, I'm going to hide all of the other objects in the model by selecting to only show selected objects from the select menu. Again, in order to see everything easier, I'm going to change to isometric view. Now let's draw the contour for the X displacement. Let's open the contour settings and select kinematics. Making sure we're looking at displacement in the X direction, all frames, and let's calculate limits to obtain our contour. Now we can scrub through the timeline showing the contour diagram until we find the frame where we see the maximum displacement based on the contour colors. Now let's chart out the actual drift. To do this, we'll go back to plan view and hide the contour. Then we can start drawing a chart for that frame. We'll look at location Z and displacement X for all of the selected elements. Now we can right-click on the chart and create a new chart that differentiates with respect to X, location Z, to show the soft story drift for all of the levels. Next, let's get the windows tiled vertically so we can see everything together. And there you have it. That's how you look at soft drift in extreme loading for structures. For more information, visit us at extremeloading.com.